Combining vectors that are at right angles, the parallelogram method. Suppose that I were asked to combine two vectors, maybe one vector east and another vector pointing north. So first I'll draw a north, south, east, and west axis. And since our vectors are primarily acting toward the east and the north, we'll focus on this quadrant, the northeast quadrant. My scale will be 1 centimeter equals 1 unit. And so first we'll look at this from a graphic perspective, and then we'll solve the same problem using basic trigonometry. Let's say we have a 4-unit vector acting due east. So I would draw my arrow 4 centimeters in length, pointing east along the positive x direction. And I'll label that vector 4. Next, I have a 3-unit vector acting due north. So I'll draw an arrow 3 centimeters in length, pointing due north in the positive y direction. To use the parallelogram method, we must move these vectors so that a parallelogram is formed. I would move my 3-unit vector over to the right and place it head to tail with the 4-unit vector. Also, I would move my 4-unit vector up and place it head to tail on the 3-unit vector. So let me do that. Of course, if you're using graphic methods, you want to be certain that you're being as accurate as possible in drawing these vectors. So here, I have another north-south line, and I'll measure to make my 3-unit vector. If I've accurately drawn this 3-unit vector, then I really don't have to measure to move the 4-unit vector upward. I simply have to connect my last 2 points. So notice that the type of parallelogram we formed here is a special case of a rectangle. As long as opposite sides are parallel, however, this method can be used with any vectors. Now my resultant is one of the diagonals of the parallelogram, so you have to ask which diagonal would make more sense here. Would the resultant be pointing in a direction going southeast or northwest, or should it be the other diagonal? Well, the resultant is a combination of a north-pointing vector and an east-pointing vector. So the resultant must lie between these 2 directions. It's a vector that points in between north and east. So the diagonal which points northeast would make more sense in this case. My resultant starts at the same point as my 2 original vectors and points toward the northeast. Now we could either measure the length of this vector to solve graphically, and I get about 5 centimeters, or in a moment you'll see that we could use trigonometry. If I measure the angle, the measurement that I get is somewhere around 36 degrees. So we could say a 5-unit vector, 36 degrees towards the north of east. To use trigonometry, notice that we have a right triangle here. Anytime we're dealing with a right triangle, we can use our basic trig functions, sine, cosine, and tangent, or we could use the Pythagorean theorem. I'll use the Pythagorean theorem to find the hypotenuse, which is really our resultant, little r, also known as c. Pythagorean theorem says that c is equal to the square root of a squared plus b squared. And it really doesn't matter which side we call side A or which side we call side B, the 4 or the 3 unit vector, because we're simply adding together the sum of their squares. So if I substitute into Pythagorean theorem, c equals the square root of 4 squared plus 3 squared. And if you do the calculation, c turns out to be 5. So we have a 5-unit vector. Now to find the direction, choose the angle that your resultant is closer to in terms of the cardinal compass directions. We could either say that it is to the east of north, or we could say that it is north of east. In this case, north of east would be appropriate because my angle theta indicated here is the smaller of the two possible angles. It's the angle across from the shorter side, so therefore it must be smaller. The tangent function would be the most appropriate function to use here, as we know with certainty the value of the opposite side and the adjacent side. Those values were given in the problem. So the tangent of angle theta equals opposite, or 3, divided by adjacent, which is 4. Next, we'll use the inverse tangent in order to find angle theta itself. So theta is the inverse tangent of 3 over 4. Find the angle. It is a 36.9 degree angle. So as you can see with mathematics, we get the same result, only mathematically our results are more accurate than simple graphic measurements. So the answer was 5 units, 36.9 degrees north of east. Now pause the video for a moment and see if you can solve the following problem. We would like to know the result of a 4-unit vector west and a 2.5-unit vector south. Pause the video, work the problem out, and when you're ready, press play again to see the solution. And here is our solution. A 4-unit vector west and a 2.5-unit vector south. And here's our final answer.